Reflection and refraction of light. The reason we can see objects is that they either emit or reflect light. Most materials don't produce their own light, so almost everything we see is reflecting light. The reflected light travels to the retina of our eyes, where an image is received and sent to the brain. You can understand this if you look around your darkened room at night. After your eyes adjust to the darkness, you're going to recognize some familiar objects. But in your head, you know that some of these objects are actually brightly colored, but in a darkened room, they look gray or black. Now, turn on the light and you can clearly see all the objects in the room, including their colors. For you to see an object and its colors, it must reflect some light back to your eyes. Now, objects can absorb light, reflect light, and transmit light, which means to allow light to pass through them. The type of matter in an object determines the amount of light it absorbs, reflects, or transmits. An opaque material like this apple will only absorb and reflect light. No light can pass through it. As a result, you cannot see inside the apple. Materials that allow some light to pass through them, like this colored bottle, are described as translucent. You can kind of see through them, but not clearly. And then transparent materials like this row of glasses here transmit almost all the light striking them, so you can see objects clearly through them. Only a small of light is absorbed and reflected. Now, every morning when you get ready, you probably take a quick glance in the mirror to check your appearance. For you to see your reflection in the mirror, light has to reflect off of you, hit the mirror, and reflect off the mirror into your eye. Reflection occurs when a light wave strikes an object and bounces off. Because light behaves as a wave, it obeys the law of reflection. According to the law of reflection, the angle at which a light wave strikes a surface is the same as the angle at which it is reflected. So why can't you see reflections or why can you see reflections in a store window, but not in a rock wall? Well, the answer has to do with the smoothness of the surface. A smooth, even surface, like that of a pane of glass, produces a sharp image by reflecting parallel light waves in only one direction. Now, reflection of light waves from a smooth surface is called regular reflection. A rock wall has an uneven surface that causes incoming parallel light waves to be reflected in hundreds of different directions, and this is called diffuse reflection. Now, when a wave of light passes from one medium to another, such as from air to water, something unique happens. The light wave bends or becomes refracted. The amount of bending that takes place depends on the speed of light in both materials. The greater the difference is, the more the light will be bent as it passes at an angle from one material to the other. Every material has what is called an index of refraction. It's a property of the material that indicates how much the speed of light in the material is reduced. The larger the index of refraction, the more the light is slowed down in the material. Many devices like glasses, binoculars, cameras, and even microscopes form images using refraction. Now look at this diagram. This circle here represents a rain droplet. This rain droplet also reflects light. The refraction of the different wavelengths can cause white light from the sun to separate into the individual colors of a visible light, showing a rainbow. Refraction of light can also create mirages, which is an image of a distant object produced by the bending of light through air layers of different densities. Mirages are results of when the air at ground level is much warmer or cooler than the air above it. All right, let's take a break here, and it's time to show what you know.